Good morning. I wanted to spend a little time on the exploration of the classification of complex adaptive systems based on the unified field framework or equation that we've been exploring over the last couple of months. Now, as a reminder, here's the unified field equation or framework, and it in itself represents one unified complex adaptive system, but any offspring complex adaptive systems that form the basis of any physical system or chemical systems or biological complex adaptive systems or human complex adaptive systems derive from this. And we saw some examples as we considered the complexification of matter through its different layers. So for instance, we had explored the electromagnetic layer and the quantum particle architecture layer, which are both the basis of physical complex adaptive systems. We had explored the atomic layer, looking at the classification of elements that is an instance of, or the basis of, any chemical complex adaptive system. And we had looked at the cellular level, which is similarly the basis of any biological complex adaptive system. And one thing to note about the classification of these complex adaptive systems is that there is an automaticity in the way that they emerge, in that they are fully integrated or part of the system. The intelligence that organizes their activity is, in a sense, part of the system and not part of the emergent complex adaptive system, and this is specified by the actions of M2 and M1. So when we're looking at the electromagnetic field, for instance, then M2, which is the set of elements that derive from the essential qualities in M3, we see that it's perhaps fair to say that M2 is synonymous with M3. So it's a small set at this point, and the elements are essentially that of presence, power, knowledge, and harmony. But as complexification takes place and experimentation or adaptation takes place, we find that these sets begin to expand, so that as it gets through the quantum level or the atomic level or the cellular level, there's more and more elements being added to these sets that basically further distinguish what presence means, what power means, what knowledge means, and what harmony means. And so they may have basically many, many more elements in those sets as this complexification takes place. And further, we had specified that there's a relationship between M2 and M1, in that M1 is the unique organizational seeds that exist in any complex adaptive system. And as the elements increase in the sets of M2, then there's a massive increase in the sets of M1, in that M1 can consist of the combinations of any of the elements in these M2 sets. So the multiplication between these different sets. So this becomes much, much larger, which is depicted by this axis of complexity increasing almost asymptotically here along this axis over here. But there's a commonality in all these complex adaptive systems, and if I were to represent that, the automaticity is from the meta layer to the untransformed layer. So this is the kind of complex adaptive system we're looking at, and essentially we may say that there's three primary types of complex adaptive systems that animate these automatic layers as they emerge. Now, when we arrive at human systems, there's a difference, because the system in itself, this unified equation, in a sense begins to project or separate aspect of consciousness from the system itself into these emergent phenomena of human beings and other collectivities that, or other complex entities that may arise. And this separation of intelligence, of awareness, of ability to act, to perceive, to serve, and so on, allows these entities to basically direct how the system, any complex adaptive system, is going to evolve. So whereas up to this point here, we had an automaticity in which the intelligence or consciousness is embedded in the system itself in these layers, when we come to the human collectivities or human systems and anything based on it, there's a separation so that awareness and intelligence can direct how the system is going to evolve. So that necessarily means that there's going to be a lot more variation in the kinds of complex adaptive systems that can arise. And as we look at this unified field framework, it gives us a sense for the classification of these variety of complex adaptive systems that can arise. And I'm going to illustrate that by essentially classifying the second set of complex adaptive systems that operate from the untransformed layer toward the meta layers, and essentially taking each of these four primary organizing principles as a separate matrix or possibility for classification. If I just think along the presence aspect, then the various kinds of complex adaptive systems that can arise could be classified as a function of xu. X, remember, is the untransformed set at this point, so physical, vital, mental, integral, which are derivations of presence, power, knowledge, and harmony. So we could have physical, vital, mental, integral, and basically untransformed versions of this that are the basis of the complex adaptive system that's arising. Similarly, we could have relatively transformed sets of the physical, vital, mental, and integral, and then we could have sets that or complex adaptive systems along the presence aspect that derive their power from M1, M2, and M3 more directly. So we're looking at 8 plus 3, 11 different classifications just along the presence aspect. Similarly, we consider the power aspect, we consider the knowledge aspect, and we consider the harmony aspect. We have therefore a total of, at the very least, 44 different complex adaptive systems that are possible. And to illustrate why these are fundamentally different complex adaptive systems, I'm just going to use a notation of, or try and illustrate this on a time-space axis to show influence of these complex adaptive systems when they're anchored along one of these bases here. So by definition, this is of course a space matrix and a time matrix. And so if you have a complex adaptive system whose seed, whose very essence is of the untransformed nature, then its impact, its ability to sustain itself in time and space is going to be lower. And let me just illustrate that by the untransformed and to the base untransformed. We have then the untransformed but to the base of relatively transformed to the action of M1, M2, and M3, and its ability to sustain itself in time and space grows. And similarly, M1, the ability to sustain itself in time and space, since it is now fundamentally constituted of the organizational seeds themselves that are animating the power in the complex adaptive system, its ability to sustain itself is higher, and similarly we would find that for M2 and M3 the ability to sustain themselves or to become meaningful centers in a more elaborate complex adaptive systems is much higher. And to illustrate this, or to draw this out, so we have this classification here, and we have the impact of a different complex adaptive system based on its seed in time and space. But then very practically the question is, what would this look like in a complex adaptive system in which many different elements that have different seeds come together? So we may represent this kind of network, if you will, as many different independent points, and there's all kinds of connections between these points here, and this collectivity is the complex adaptive system that we're observing. However, based on what the seed that's animating each of these points are, so for example, if you have a seed that, say, is at the PU layer or the PU type, so let's represent that by PRPU, then its power, its ability to sustain itself in time and space will never be as much as, say, for instance, a system that has as its seed the integral transform. So we have PR presence transformed, and the influence of this point here is by definition going to be much larger. And so we would find that a system that had this kind of setup, and of course this is just an illustration, but there's 44 different seeds here that can exist in this network, and we would find that there would be a convergence on those centers that have a more impactful seed as defined by its impact in time and space, its ability to sustain itself in time and space. Now, so this here is number 3, but then what we may find also is that over time, the question is, how might such a system evolve? And I'm going to represent that by saying that what we should see in kind of consonance with how each of these stable layers have evolved, the electromagnetic, the quantum particle, the atomic, and the cellular, where there's a fourfold scheme that is unified together by perhaps a macro action of, we may call it love or the power of integration or unification. But similarly, what we could expect is, as a system, a human-based complex adaptive system evolves, then we would similarly have 4 bases. And the point where all of these 4 intersect is going to become the center of that complex adaptive system, because it's allowing a lot more energy of the field to emanate and organize things around itself. But if we look at this, there's likely going to be a process of iteration between these, because the kinds of fourfoldness as specified, for example, in any of these matrices, could be along the physical, the vital, the mental, or the integral dimensions. And so we would expect that we would therefore have a third classification. So we had these classifications MU, we had this classification UM, and now we have this classification that perhaps I will call untransformed, that would comprise essentially of 4 kinds of seeds, primary seeds, which would be the physical transformed, vital transformed, mental transformed, integral transformed. And so we have, as a basis of just preliminary classification, 3 plus 44 plus 4, which goes to over 50 kinds of complex adaptive systems that we need to think about, we need to get our arms around, and we need to understand the interaction between these different types of seeds or complex adaptive systems as they come together and impact a larger complex adaptive system. So there's been thought, and the reason why I'm exploring this is because there's been thought that all complex adaptive systems are similar, but I would make the case that in fact they are not, and there is as much variety in complex adaptive systems as perhaps we would see when we look out at the thing called an animal or the thing called a plant, for instance.